Hello guys, today we will discuss Drago's rule, that is very important rule related to hybridization. If we consider the bond angle of NH3, PH3 and ASS3 and SBS3, so there is a large difference between the angle of NH3 and all other these hydrides. Means we can say the bond angle of PH3, ASS3 and SPS3 is almost same, that is around 90 degree, but the bond angle of ammonia is different, that is 107.8 degree. Similarly, if we consider the H2O, so bond angle of H2O is approximate 10.4 degree. That is quite different from the bond angle of other element like H2S, H2SC and H2T, that is around 92, 91 and 90.5 degree. Now, what is the reason behind that? We have to consider that first of all we all know that N, P, AS and SB, then BI, these all are the elements of group number 15, and oxygen, sulfur, selenium, tellurium and polonium, these belong to group number 16, and that is our period number 2, second period elements. Nitrogen and oxygen are second period element, then phosphorus and sulfur is third period, then fourth period, and that one is fifth period. Now we have to consider that, we have to observe that what is the reason behind that there is a large difference between the bond angle of ammonia and all these three elements hydride. There is a large difference. What is the reason behind that? Why this large difference occurs? It cannot be explained through VBT, hybridization theory, or MOT. Hybridization, MOT, these theories cannot explain what is the reason between that large difference. So why this difference occurs, we have to understand. We should take one example. First of all, NH3. We all know the N electronic configuration is NS2 NP3. So in S orbital there are 2 electrons and in P orbital there are 3 electrons. In the case of NH3 there is sp3 hybridization, means 1 s orbital and 3 p orbitals mix together and exchange their energies and generate 4 new hybrid orbitals. These new hybrid orbitals have equivalent energy and symmetrical shape. So that hybridization is known as sp3 hybridization. sp3 hybridization. In sp3 hybridization, generally the bond angle is 109 degree 28 minute. That is true. The bond angle of ammonia is approximate 107.8 degree approx. So it's almost similar. We can say there is no large difference between bond angle of tetrahedral shape sp3 hybridization general bond angle and the bond angle of ammonia. Why bond angle of ammonia is slightly less? That is because of there is lone pair bond pair repulsion. We all know that according to VSEPRT theory, we can explain it. We can explain why the bond angle of ammonia is lesser then 109 degree 28 minute, because lone pair repel bond pair. That is true. Okay, but when we consider the case of PH3, now how, first of all we have to observe that one is also how molecule of NH3 is formed. So we can explain like that. In NH3 there are three hydrogen will overlap these three sp3 hybrid orbitals. Sp3 hybrid orbitals, that is also sp3 hybrid orbital, that is also sp3 hybrid orbital, that is also sp3 hybrid orbitals. So we can say the lone pair of nitrogen, the lone pair of nitrogen in the case of ammonia are present in which orbital? That orbital is sp3 hybrid orbital. That orbital is sp3 hybrid orbital. And what is the s character in sp3 hybrid orbital? So there is 25% s character are present in s orbital of nitrogen atom in the case of ammonia. Now consider about PH3. The bond angle of PH3 is very less. It's around 94 degree. So why, what is the reason behind that? It cannot be explained through hybridization theory, because we all know what is the configuration of phosphorus in PS3. The configuration of phosphorus in PS3 is again NS2 NP3. So there are two electrons present in s orbital and three electrons are present in p orbital. Now this p orbital means that is like px, py and pz, and we all know px, py and pz, these three orbitals are adjacent according to 90 degree, means in unhybridized condition, means if these p orbital are not taking participate in hybridization, then the bond angle, or we can say the angle between these p orbital is 90 degree, means px, py and pz, these three orbitals aligned 90 degree in any atomic in any atom. P orbital is aligned to each other is 90 degree, and its bond angle is also approximate 90, means 94. So what is the meaning of that? Its meaning is that these p orbital might be not taking participate, not participating, not participating in hybridization, in not participating in hybridization, because they have a large p character. So we can say how this PS3 molecule is formed. This PS3 molecule is formed, we can say no hybridization, we should not consider the hybridization, because bond angle, its bond angle is approximate similar to angle between pp orbital. It means directly overlapping of hydrogen atom with these three p orbital, means these three p orbitals directly overlap with hydrogen atom, directly overlap with this hydrogen atom. So no need to consider hybridization. So now where are these lone pair, means lone pair are present in which orbital? So we can say lone pair are present in s orbital. So lone pair of p in PS3 are present in s orbital, which has maximum s character, maximum s character, or we can say approximate 94% S character are present. And we all know if S character is more, then electronegativity of atom will also more. And if S character is more, then electron will be closer to nucleus. So we can say these lone pair are more closer to nucleus of phosphorus. That's why this phosphorus cannot give easily electron, cannot donate easily electron. So that is the reason. So that rule is called as Drago's rule. So when we consider the Drago's rule, we should not, we according to Drago's rule, we should not consider the hybridization. What are the conditions for Drago's rule? There are some conditions when we apply this Drago's rule. First of all, the electronegativity of central atom should be more than 2.5. The element should belong to third, fourth or fifth period. It should not be belong to second period. Means we should not apply the Drago's rule on NH3 and H2O. We should not apply the Drago's rule in NH3 and H2O. Means in the case of NH3 and H2O, we should consider the hybridization, that is sp3 and sp3. But all the hydrides that are below the NH3 and H2O, means belong to third and fourth, fifth onward, these periods on which we can apply the Drago's rule. Next one is there should be sum of sigma bond plus lone pair should be 5, and means sp3 hybridization, and at least one lone pair should be present on central atom. Then we can, in if any element or if any compound fulfill that condition, we can apply Drago's rule on that, and according to Drago's rule there is no need to consider hybridization. No need to consider hybridization. That is the reason that the bond angle of these all is around 90, because we should not consider the hybridization in these molecules. And lone pair of these elements are present in pure s orbital, or we can say S character is more. If S character is more, then electronegativity is also more. That's why these elements do not easily donate the electron. That is the reason that NH3 can be easily dissolved in water, because in NH3 the lone pair are present in sp3 hybridized orbital, in which S character is 25%. So S character is less, that's why electronegativity is less. So we can say these lone pair are far from nucleus, so these lone pair can be easily donated to water, and we will get NH4OH, and ammonia can easily dissolve in water. As well as similarly NH3 when react with HCl, it give white fume of ammonium chloride, white fumes of ammonium chloride. Why? Because it can easily donate its lone pair, because S character is less, that's why electronegativity is less, that's why the lone pair are far from nucleus. But in the case of PH3 is almost insoluble in water. It is not soluble in water because its lone pair are present in s orbital, because we are not considering hybridization according to Drago's rule, and lone pair are present in s orbital, that's why electronegativity is less. 100% S character, 94% S means electronegativity is more, that's why these lone pair are more closer to nucleus. So these lone pair cannot donate easily, that's why PH3 does not or soluble in water, as well as PH3 is almost not reactive with HCl because it cannot donate its electron easily, because same reason, S character is more, so electronegativity is also more, so electron are more closer to nucleus, that's why it does not donate its electron. So that is called Drago's rule. So what is the summary for Drago's rule? Summary for Drago's rule, that according to Drago's rule, if in any compound or in any hydride the electronegativity of central atom is more than 5, the element central atom belong to third, fourth, fifth, sixth period, it should not belong to second period, it should not belong to second period, and the sum of sigma bond and lone pair is equal to 5, means sp3 hybridization, and at least one lone pair on the central atom should be present. Then according to Drago's rule, there we should not consider the hybridization, means no need to consider the hybridization. So the lone pair are present in almost s character, s maximum s character or pure s orbital, that's why we can say the lone pair cannot be donated easily. Thank you.